Okay, for this first problem, I went ahead and got the derivative so it would save a little bit of time. So when you have to go find concavity, you have to go all the way to the second derivative. So I found my first derivative, and then from there I had to use the quotient rule for my second derivative. And I cleaned it up, and I finally got to that. Now, when I set this thing equal to 0, I need you to think about this. If you set this equal to 0, when we had equations like that, if I multiply both sides by the denominator, I end up with this. So if I just set my numerator equal to 0, let's see what that gets me. I'm not going to see my numerator. So negative 2x squared plus 16x plus 40. You do a zoom 6. So it hits there, and it looks like it hits over there. So let me make my window go more, a little bit more that way. Let me do 15. Now if we go do our zeros, second count 0, that would be a negative, say 3, 0, and I don't guess. So 1 0 is negative 2, so it's below, so I'd have a minus, I'd have positive and a minus. My other 0, it looked like it was at 10, 8, and 12. Okay, so now I went ahead and did my sign chart. So there's my zeros. It's below, it's above, and it's below. And when you're doing the second derivative, remember you use baby parabolas. So this thing's concaved up from 2 to 10, and concave down from negative infinity to 2, and then again from 10 to infinity. Or written, it would be like that. So that's that problem. Let me go get number 16. Alright, so I went and got my first derivative, my second derivative, and then I graphed the second derivative. So 12 shift e to the x minus 4 shift e to the 2x. So it looks like I have a 0 there. So what I've got so far, I've got that. I went and found the 0, but let me show you another way. I'll go find the 0, just double check. Okay. Another way I can do this, if I set this equal to 0, I'm going to factor out a 4 and an e to the x. If I factor that out of there, I'm going to have a 3 minus e to the x equals 0. This can never equal 0. That's an exponential, and that can't equal 0, but this can. If I had to do it by hand, I'd set that equal to 0, and now I'd take natural log of both sides. And when I take natural log of this side, I get natural log of 3 is equal to x. Now remember that number, because if I do natural log of 3, that was that number I had a minute ago. And it was above and it was below, so it's concaved up from negative infinity to that value and concave down from that value to infinity. Or that. One more problem that you asked about. Find the absolute maximum on that interval for that function. So I had used the quotient rule, and when it asks for max or min, I'm going to be doing my first derivative and a sign chart. So I did that, and I factored out. So I know that set equal to 0 would be 0. This would be negative 6. So I did my sign chart. But The only issue was the interval they gave me was 0 to infinity, so I have to look from here that way. And if I do that, I do not have any sign changes. So you were right in that there is no absolute maximum on that particular interval for that function. Hope that helps. Thank you.